Okay, so here's the equation we're trying to solve. Here are those four rearrangements that we did, turned into iterative formulas by putting n plus 1 here and n on the right hand side in our g of x, that we rearranged it to be x equals g of x. We're going to just quickly look at how to use those on a spreadsheet, which you can do even if you haven't got Excel. You can get into Excel online with your Office 365 sign in with your school login. So you could practice on that. And there's also a spreadsheet function in your calculator, but as I'll show you, it's not quite as easy to use as Excel. So anyway, here's the equation we're trying to solve. Remember that we tend to write things with f of x, so we'd at some point in this question have defined f of x to be this side, and so what we're trying to do is solve f of x equals 0, which is the same as this equation up here. So let's just quickly look at the graph of y equals f of x, or y equals this quintic, to see how many roots it's got and whatnot. So here's the graph. You can see there's one root between -1 and -2, one root between 0 and -1, and one root between 1 and 2. Okay, so it's got 3 roots despite being a quintic, so it could have had up to 5, but this wiggle happens down here. So it's got these 3 roots. Will we be able to find them with the rearrangements we've got? That's the question. So we're going to try and find them. And if we've got all 3 roots, then we've got the solution to the equation. So that's a little bit of terminology that is a bit peculiar. The exam board think of the solution to an equation as all its roots. Okay, we'll come back to that. We'll recap that another time. Oh, that's not what I meant to do at all. So going back to here, what we're going to do is look at a spreadsheet. Okay, so let's just try and find, to start with, the root between 1 and 2. We'll use 2 as a starting point. So I'm going to put 2 in the top of each column, and then underneath I'll get Excel to work out the next version. So this is x0, and I'm going to work out x1. So stick an equals at the front. Now in the first rearrangement, it's 1 over a big old expression, so I do 1 over, open a bracket, 4 times by, and I can click here, or I can press the up arrow to get a2 in it, or I can type a2 in, to the power of, shift 6 to get that carré, whatever that's called, upwards arrow, and then the power 4 minus 7 times a2, shift 6, the power of 2, close the bracket, boom. So that's x1, and the great thing about Excel is that if I manage to grab the handle properly, when I get this handle to turn black, I can drag it down and it works a load of them out for me. Right, so what's happened there? It's got small, close to 0, it's got big and negative, it's got massively small, because that's times 10 to the minus 10, that's really small, massive and negative, tiny again, massive and negative again, and then Excel's lost the plot and can't handle numbers that big anymore. So that diverged, that rearrangement didn't work with the starting point of 2. Let's try the next rearrangement down this one here. You might want to pause and try and enter your own formula, see how you get on, but otherwise just follow me. Right, so I'm going to put that whole thing in a bracket and then do it to the power of -1/3, because I have to do it all on one line. So 4 times x0 squared minus 7 all to the power of, and if I want -1/3, I'm going to put the -1/3 in the brackets just as -1/3. Okay, and again copy that down. Oh look, it's zoomed in on a root about -1/2, so that's found us that root there, or it's found a very good approximation of it, I should say. Cool. Let's try this rearrangement here. Again, you might want to pause it and type in your own formula and just check that we agree. So this is the cube root, so that's power 1/3. So I'm going to do one big set of brackets and then a bracket for the top of the fraction. 4 times that to the power of 5 minus 1. Close the bracket of the top, over 7. Close the bracket, so that's my whole fraction. Now I want that to the power of 1/3. Okay. Again, if that was a bit quick for you, you can always you can always go back and watch it again and pause it. So this one again, what's going on? It's just getting huge, really huge. Excel can't handle it anymore. It's diverged in a positive direction. That's not any use to us. Let's try this last one over here. So it's a fifth root. Again, it's a fraction, so I'll go equals bracket, bracket. 7 lots of x to the power 3 plus 1, close the bracket, divide by 4. And the whole thing to the power of, I could write a fifth as a fraction. I'm just going to put 0.2. Okay, so there we go. That's my first value, that's my x1. And that does seem to converge on a root as well, 1.36-ish. So with that, with those 4 rearrangements, with the starting point of 2, we found this root and we found this root. We haven't found that one down there, but we were starting at 2. We weren't starting over near this, so let's start near it. Let's stick -1 in instead and see if we find that other root. Something weird's happening with that one. Still the same root. Same root as we found before. Aha! So there you go. That has found us minus 1.2766. I say it's found it. Obviously we haven't found exactly the root, but we found a really good approximation to that root there of the equation. And obviously we didn't have to go through the steps of deciding what it is to however many dp and then doing a change of sign to prove it. But that's how you use Excel to do fixed point iteration. Okay, cool. I'm going to do a separate video showing you how to use the calculator spreadsheet function, and that'll probably be next lesson. Good luck with the questions.